is about using Smith chart. So the Smith chart you can actually download from the website Google, and then you can actually learn. You can observe the points in the Smith chart. So when you want to find the certain the point that is related to a certain load, you have to first like normalize the load value, and then you have to point out the value in the Smith chart. So so when you are like given a circuit, for example, we are given a certain circuit with a certain load. Let's say it is like 10 plus 20 J, let's say. And then we are asked to find the reflection coefficient at the load using the Smith chart. So first you have to find the point that corresponds to the load in the Smith chart. But also we have to remember that the Smith chart only has the normalized values. So first we have to find the normalized value of the load. So you can do that by dividing the load value by the characteristic impedance of the line. So you will find the normalized value, and then you will find the normalized impedance value in the Smith chart. And the Smith chart is composed of circles and arcs, right? Basically, so you have to find the corresponding circle first, and then you have to find the corresponding arc and find the impedance, the intersection of those two, the arc and the circle, to find the intersection point of those two, the circle and arc, to find the load point, right? So if you have point 2 here, you have to find the circle that corresponds to point 2. So there are certain circles in the Smith chart. So in this Smith chart, you can see that so starting from here, there's a circle with 10, number 10, 5, 4, 3, 2, 1.8, 1.6, and so on. So when you want to find where point 2 is, you have to go here, right? Point 2 circle, and then you have to find the arc, 0.6 arc. So 0.6 arc you can find right here, and then you will find some intersection over here. So the circle that corresponds to point 2 is somewhere here, and then the arc which corresponds to 0.6 is somewhere here, and then let's say that arc is here. So the corresponding point is here. So the corresponding load point you can find here, and then the reflection coefficient you can find using the radius that you can measure from the center of this circle towards this load point. So this is the magnitude of the reflection coefficient. The angle of the reflection coefficient you can find using the angle from the angle that you can measure from the scales. So in this Smith chart, the angle of reflection coefficient scale is given. So what you have to do is, once you know the point up to which you need to find the angle, you measure the angle from the x-axis towards that point, and then you can find that angle in degrees. So you can using that you can find the magnitude and the angle of the reflection coefficient. So the reflection coefficient you can find from the Smith chart. So basically the radius from the center point of the Smith chart. The center point of the Smith chart is a point where you get the 1.0, right? 1.0 point, and then from that point you measure the radius. So 1.0 towards the load point, and then you find the angle from the scale, and then you will write that angle, let's say it's alpha, right, in degrees. So this is the reflection coefficient. And then you have the load admittance. So load admittance, in order to find the load admittance, you have to take 180 degrees from the load point, right? So 180 degrees from the load point means exactly you are taking like the opposite point in the Smith chart. So you have to take the opposite point. That means like you have to take the magnitude from the center to the load point and mark it on the exactly opposite point, which is like 180 degrees from the load point, and you will get this point, which is the point that correspond to the admittance of the load. But that point is giving the normalized value. So in order to find the actual value, you have to multiply the admittance value that you get from the